Okay, example 8. If I want to solve 9x squared is equal to 64, since there are no other x's around, you could just divide both sides by 9 first, so that you get x squared by itself. Right? Then you get x squared is equal to 64, and all you have to do then is square root both sides. Then you get x equals to square root of 64 over 9, but don't forget to put positive or negative, because there's two ways for this to be true. So then you get x equals to, of course, square root of 68 over square root of 9 is 8 over 3. So there are two possible ways for this to be true. So x could be negative 8 over 3, or x could be negative 8 over 3. Okay, so that one was pretty straightforward, but what about this one here? 0 equals to 4x squared minus 0.48. Again, you have the x squared by itself. There are no other terms with x, so you first add 0.48 to both sides, so you get 0.48 equals to 4x squared. And since we want to get x squared by itself, divide both sides by 4, then of course you get 0.12 equals to x squared. Then all you have to do again is square root both sides, and when you square root both sides, you got to put positive or negative. Yeah, so when you do that, oh, before I do this though, how do we then deal with decimals? So we have to then rewrite 0.12 as what? Before we put plus or minus square root 0.12, I think it's best to rewrite 0.12 as, anybody know how to write that as a fraction? It'd be, yes, 12 over 100. And then you square root both sides, and of course put plus or minus. Then this becomes positive or negative square root of 12 over 10, because really square root of 100, isn't this square root of 12 over square root of 100? So square root of 100 is nothing more than 10. 100 is a perfect square. So you get x equals to positive or negative square root of 12 over 10, but we're not quite done, because square root of 12, you can simplify further, because 12 is really 4 times 3, isn't it? Square root of 4 times square root of 3. So square root of 4 is really 2, so therefore you could write this as 2 rad 3 over 10, positive or negative, but we're still not done, because 2 goes into 10 also. So you should simplify this as positive or negative square root of 3 over 5. So there's your answer. And lastly, let's review how to simplify these expressions that has variable in them when we're dealing with square roots. Square root of x, we know that x has to be positive, because if x was negative, then it's not on a number line, it's not defined as a real number. So we know that x has to be positive. Now keep that in mind as we then simplify square root of x squared. Well, we just talked about that as being not just x, but it has to be, yes, right, absolute value of x, because we want to make sure square root of x squared is, when you simplify square root of x squared, it has to come out to be a positive number. If you leave out the absolute value, then you're saying square root of x squared could be a negative number if x happens to be negative, which is not true. So you need to have absolute value there. But what about then case for x cubed? What can we do with, how do we simplify this? Well, x cubed, then has to be is x square root of x squared times square root of x, isn't it? And now, do we need to then leave the, didn't we just say square root of x squared is absolute value of x? Well, in this case, you don't really need to put that absolute value of x, because it's really redundant, because we know that x has to be positive for this to be a number on a number line to be defined. So we just we do not need to put absolute value there, because we know that x is inside a square root. Okay, so whenever there's a variable, after you simplify all this, whenever there's a variable inside the square root, then you don't need to put in any absolute value there. Okay, what about then square root of x to the 4th power? That's square root of 2 times square root of 2. Then do we need, again, absolute value on both of these? Not really, because really this is x squared, and every time you square a number, it's always positive. So not only does it work for x to the 2nd power, if it's x to the 4th or 6th or x to any even power, after you simplify, you do not need any absolute value. Okay, again, that would be redundant. What about x to the 5th? Well, that's x squared, square root of x squared, square root of x squared times square root of x. Again, you get x squared times square root of x, And as you can see, you won't need any absolute value, because not only is x being squared, x is also inside the square root. So you just leave that. Now what about the next square root of x to the 6th power? Then isn't that square root of x squared times square root of x squared times square root of x squared? Well, that's just x to the 3rd power. Now, it's x to an odd power, so do you think we need an absolute value, or do you think we could just leave it as x to the 3rd? Yes, we do need the absolute value, because anything to the odd power could be negative, and so we want to make sure when we simplify square root of x to the 6th that the answer doesn't come out to be negative. So we want to make sure that we put an absolute value there, because it won't make any sense for it to be a negative number at the end. Okay.